Algebra 3.6, proportional relationships, take 82. Don't forget to write down today's date. Proportional relationships. A relationship is proportional if its equation is of the form y equals kx. K cannot be equal to 0. The graph must also pass through the point 0, 0. Not as good as take 83. All right, so proportional relationships is a relationship is proportional if its equation is the form y equals kx. The graph passes through the point 0, 0. Another thing on there as well that I don't have written is that if you look at the table below, the personal trainer pay for Joe, there's going to be a relationship here, a constant rate. So if we go y over x, 45 over 1 is going to equal 90 over 2, which is going to equal 135 over 3. It forms a proportion, hence proportional relationships. So if we look at personal trainer pay for Joe, we have the number of clients are 1, 2, 3, 4, and 5. The pay is 45, 90, 135, 180, and 225. We want to, figure out what is the common difference, and then write an equation. Now, you can do this problem writing the equation like you know, using a to the n is equal to a sub 1 plus n minus 1 times the common difference. Trust me, if you go through and do that process, you're just going to get this. Y is equal to, our common difference is 45, 45x. So our equation for this one is y equals 45x. Again, over here, if you did it real quick, it would be 45 plus n minus 1 times d, which is 45. When I multiply that out, I get 45 plus 45 and minus 45. The two 45s cancel each other out, and I just get it to equal 45n, which is, again, y equals 45x. So we have the equation in the form y equals kx. It is y equals 45x. The graph. Okay, we need to graph this. Well, remember, we are graphing y equals 45x. So if x is 1, 2, 3, 4, 5, just like in the table above, we have 45, 90, 135, cheat, 180, and 225. Okay, when I graph them over on my graph, the one thing that you have to be careful of, and that is my x values going across, I'm going to count by ones. But my y values now I need to count by something different than 1 because I need my values to increase much faster so I can plot the point 5, 225. So I can plot this point on my graph. To be able to do that, I'm going to count by 50s. So this will be 50, 100, 150, 200, 250, so forth. So at 1, we're at 45, which is just under 50. 2 is 90. 3 is 135, somewhere in here. 4 is at 180. And 5 is at 225. And when I draw my line for this problem, it's going to go through 0, 0, and those values. And I actually did pretty good. That's probably the best one out of my 84 takes. All right, so y equals 45x. I am joking on the 45th take. It's only my 12th. Still kidding. All right, and some of you are thinking, yeah, and you should have did a couple more. But I like my humor. Remember, I am the funniest teacher that you'll ever know. So go to the next page, and on the next page, we're talking about predict Joe's pay if he has 8 clients. Okay, so again, our equation, y, on about half of the takes that happens, y is equal to 45x. So it's going to be y is equal to 45 times 8. And when you do that math in your head, you get an answer of 360. So Joe's pay is going to be $360 for 8 clients. Here's another one. Joe's soccer team donates for each goal. Number of goals and the donation. We're going to write an equation, we're going to graph, and we're going to predict the donation with 12 goals. First of all, writing an equation, our common difference is 75, so it will be y equals 75x. The graph is going to come off of that, and then we're going to predict. Okay, you can predict from the graph or do the math either way. Y equals 75x. So when I do my table, 1, 2, 3, 4, 5, we have 75, we have 150, 225, 300, and 375. Again, my x values, my x number line, I'm going to count by ones. And my y values, I need to count by something different than ones. In this problem, I'm going to count by 50s again, still. You could count by more. 150, 200, 250, 300. So 1 is going to be at 75, 2 is at 150, 3 is at 225, 4 is at 300. I'm not going to fit 5 in on this one, but it will give me a pretty good idea on where we're at. And it's going to go down here, and it's going to go through 0, 0. So we have a graph, we have an equation, and then the next one it says predict the donations if we have 12 goals. So that would be y equals 75 times 12. 75 times 12. And 75 times 12 is 900. So y is going to equal $900. Y will equal $900. On the next page, we are now going to talk about a non-proportional relationships. And with the non-proportional relationships, a value added to y equals kx. We have still the y equals kx. Okay, and the graph does not go through the point 0. The value added to y equals kx. So when we add a value to this, we're going to have something like y equals kx plus or minus plus some value, I'll say b. Okay, in a non-proportional relationship, this is what your equation is going to look like. In a proportional relationship, that is when you'll have y equals just kx. Also, the graph is not going to go through the point 0, 0. And one other thing that I don't have in the definition is that the ratio or the proportion, the points need to form a proportion. In the table here, you'll notice changing y over change x, we're going to have 9 over 1 does not equal 12 over 2 does not equal 15 over 3 does not equal 18 over 4. Now, some of you might have asked in the first set of problems or in this problem, why did I go 9 over 1 versus going 1 over 9? Well, you can go 1 over 9, but that's still not going to equal 2 over 12, still not going to equal 3 over 15. Doesn't matter how you do it as long as you're consistent throughout it. Either way, does not proportional. Non-proportional, therefore, the problem is non-proportional relationship. Now, writing equation, I'm going to come back to writing an equation in just a second, but let's graph these points. When we graph these points, 1, 2, 3, 4, and the other values, I'm going to use 1 for my x values again, counting by ones. But counting on my y's now, I can't count by ones. It won't fit, it won't work. So I'm going to count by fours. So it's going to be 4, 8, 12, 16, 20, and 24. My values, again, I'm at 1, we're going to have 9. At 2, it will be 12. At 3 is 15. At 4, it is 18. Okay, when I draw my line here, you will notice it does not go through the point 0, 0. It does not go through the origin. Okay, it's going to go through some value here. Okay, it does not go through 0, 0. So there's your graph is going to show that it's non-proportional. Now our equation, right away when you write the equation, you're going to write y equals, because we're adding 3 each time, it'll be 3x. But notice if I put a 1 in for x, y is going to equal 3 times 1. That equals 3. That does not equal 9. I need it to equal 9. Now we could keep doing trial and error, or we could fast forward. What value do I need to add to the 3x, or subtract, but what value do I need to add to the 3x so that I get 9? Well, it looks like I'm going to have to add 6. So y is equal to 3x plus 6. Let's try that. If we put in a 1 for x, it works out to 9. Good. Don't stop there and think that you have everything right. You probably will, but you may not. So you need to try the other points as well. 3, put 2 in for x, and we get 6 plus 6 is equal to 12. That one also checks. Let's do one more just to make sure. The third point, 3 times 3 is 9, plus the 6 is 15, and that one checks as well. Now I'm pretty sure that that works. So my equation here is going to be y equals 3x plus 6. Notice this is not y equals 3x. Again, we are adding some value. So again, we are showing that it is non-proportional. Okay, again, we are showing that it is non-proportional.